All right, so we are going to be practicing reduction of order. In this type of problem, we're given a differential equation and we're also given one solution. And our goal is to find a second solution. These two solutions will make up our fundamental set of solutions, and we'll be able to build all of the others from those two. So if you want to follow along in the notes packet, this is from the section 3.3, 3.4, goes through in a bunch of detail this kind of example. Okay. So let's take a look. So we are going to solve this. So we know one solution, and we're going to try and build another one. So our strategy is we're going to guess that our solution is just a multiple away from the original. I'm writing u of t times t squared, but often when we write this out, I'm just going to just write u times t squared. And we're going to just assume that u is some function of t. Okay, so this is a solution. So we're saying this is also a solution, so we're going to take derivatives and put it back into our differential equation. So we start by finding our first derivative using the product rule. So we have u prime of t squared, u prime times t squared plus u times 2t. And then we're going to take a second derivative. So we get u double prime times t squared plus u prime times 2t. Okay, and then this second term now we need to take derivatives of. So this first part was just the derivative of u prime times t squared. Now up next, we're going to do derivative of u times 2t. Okay, so we have u prime times 2t plus u times 2. Okay, so we were taking turns calculating derivatives. Okay, and now what we're going to do is take these solutions and we're going to put them back into our differential equation. All right, so that differential equation is right here. So our first term is going to be t squared times y2 double prime, which is second derivative of u times t squared, plus 4 u prime times t, plus 2 times u. And then we're going to take minus 4t times the derivative, u prime t squared, plus 2 ut. And then we're going to have 6 times our original function, which was just ut squared. Alrighty, okay. We are going to just rearrange terms a little bit, distributing and rearranging. So out of this first term, we have t to the 4th times the second derivative of u, plus 4t cubed times the derivative of u, plus 2t squared times u, minus 4t cubed times the derivative of u, plus 8t squared times u, plus 6 ut squared equals 0. Okay, we see there's a little cancellation going on here. We have 4t cubed u prime, and we have minus 4t cubed u prime. So those guys cancel out. And we see 2t squared u plus 6t squared u. Oh, I lost a negative sign here. So this should have been a minus 8t squared u. So what we are left with here is t to the 4th times the second derivative of u equals 0. So the second derivative of u is equal to 0. And so we can integrate this. U prime is going to be a constant c, and so u is going to be ct plus d. Our solution then, y2 of t, is u times t squared. We already know about t squared as a solution, so I'm just going to set c equal to 1 and d equal to 0. So I'm going to take just one copy of this t times t squared, which gives us t cubed as our second solution. We could have also brought the whole kit and caboodle with us. This gives us ct cubed plus dt squared. This would have been fine as well. We would just choose values of c and d. We already know that t squared is a solution, which is why I had kind of left those terms off. Okay, great.